Hello and welcome to another devlog of the sample game that I am using for a number of assignments and demonstration videos where I'm showing you, as well as those videos, all of this behind the scenes where I actually make the thing and do regular problem solving and game development, trying to make a game. So we have, where are we at? It's been a few months. Hello. We have a we got a basic player movement. They don't collide with the walls. We got to fix that. We're doing kind of a Binding of Isaac kind of game. And what I want to add today is a dash in your facing direction mechanic where you will teleport basically some number of units towards the mouse or towards the direction you're pointing your twin stick. So it's kind of like a Binding of Isaac-y, bullet hell, Zelda chamber thing where you just go into a room, you have to clear the enemies, go to the next room, repeat. Very simple. Why are these walls not colliding? Because they have no colliders on them. But those are just box colliders, right? Did we ever test our movement with collision, or did I just somehow? Yeah, there we are. Okay. And the reason that we need to worry about hitting the walls is because we want to make sure we can't dash through a wall, but that we can dash through enemies. So we want to be able to teleport, basically. The dash is really a teleport with a visual trail that shows your movement, and maybe it takes time. Maybe we show an animation of it going from A to B. But in terms of the character controller and the collisions, it's a teleport. So how we're going to do it, my plan is to use something called a raycast, where we're going to draw a line out a certain amount of distance. And if we don't hit anything, then we know we can go there. We can use that as our teleportation target. But let's say we are close to the wall. Let's say we are close to the wall, and we want to raycast teleport in this direction. We want to make sure we stop and then find this point here, so you can only go as far as the wall. You can go through enemies and maybe even end up on top of enemies, or maybe you have to be clear of enemies at your location, but you can go through them. Not sure, but let's start with the avoiding the walls, and we'll figure the enemy thing out later. I don't even have enemies in the game right now, so it's like, we can't worry too much about that stuff. So we're going to use a raycast where we just draw a line out, but we're not actually going to use a raycast. We're going to use a Rigidbody cast, which is going to take all of the colliders and the shape that they make up, and it's going to cast that. In this case, it's just a circle collider, so we could do a circle cast, but I'm going to write this code in a way that if I change the shape of things, it'll just kind of keep working. So if we make it a box or something, it won't break anything. So that will take the shape of the colliders and it will cast that out instantly, over in one moment until it hits something. And we're going to limit the distance of that. And then if we're clear, we will teleport to that location. So let's get started. We have the agent movement script, player input, player weapon handler. Well, but no, it doesn't go in weapon handler. This is a movement ability. Could be a weapon, could be like an item that you have or don't have. But we're going to put it in the movement script, and we'll leave it there in agent movement. We could put it in its own script in like dash ability that works with an agent movement. But I think I'm going to put the actual dash code here, and then we'll expose some events in the future to get feedbacks, and we'll have a Boolean that can toggle it on and off in this script. And maybe if we want to make an item, we can just connected to that Boolean. That's good enough for now. But here we have our reference to our rigid body, and it's where movement goes. And if we refactor later and split this functionality into smaller scripts and pieces, that's fine. That's fine. We know that refactoring is part of the process. So let's add a dash. let's just think of what the minimum amount is, right? We need to say, I want to move in a direction. Okay, and let's just do that. So we need some dash settings. So let's make a little header here, and we'll do a serialized field private float for our dash distance. We'll do a serialized field private float for our dash cooldown. We're not going to worry about cooldown yet. I'm going to add that to my to-do. We're just going to get the basic working. We're going to dash this far. So if we take our position, and we take our direction and normalize it so it has a length of 1, and we take that normalized direction and we multiply it by our dash distance, then and add that to our current position, and we should be good. Something like that. This isn't doing the physics. The raycast isn't doing anything. This is just like viable. Like, let's get the input in. This is the most basic version of the dash. We just instantly teleport there. So on player input, let's see if, how do we want to do, what button should dash? We're just in the mouse direction, so that leaves me, if mouse is input, that leads me to want to like make the mouse the input. But I also think that that's wrong. I think I went like spacebar to do it. We can try both. Unity engine dot input. I'm just disinvigorating because I'm in an input namespace. So I can't just type input because that would refer to the namespace and not the Unity class. So Unity engine dot input dot get mouse button down 1. Agent dot dash and yeah. So facing direction, right? Rotate to, yeah. So that should be our facing. So we should dash in that direction. All right. So I'm not worrying too much about. I think that moving to the top left is like a screen. Cool. Let's change our dash distance to 1. Yeah. How about 3? So one problem is we go past the mouse. I kind of like that because I want that distance to be fixed. Are the bullets just hanging out? That's fun. That's a future problems. Yeah, I mean, it feels good, right? If we're shooting over here. I almost kind of want it to be away from you. Because that's kind of, maybe we should like have a backwards dash. Oh, and I went through the wall. Check it out. I am able to teleport through the wall with the dash mechanic, which we want to prevent. So let's just start with that. Let's just start with the dash mechanic. To do that, we need to do our cast, right? So in our dash script, we have this, think of it as an array, a position and a direction as array, and we're going to use that to raycast. But we're going to use a raycast. My cat's vomiting. I got to pause this. I got to... Okay, I'm back. I have hardwood floors all over the apartment. And he chooses the mat, the welcome mat to yak on. Okay, I just washed my hands, so I'm still. What was I doing? We're doing a cast. A cast is. Well, let's look it up. Into the scripting API. Actually, here's a bit of advice. if you go to the help menu and you go to scripting reference from there, it'll always open up the correct version that you need, the same version that you're using. For example, there are some new C# features in C# 8, which Unity 2021.2 now supports, and I'll be upgrading this project to that just to future-proof these videos pretty soon. Rigidbody Cast. But you never want to be, looking at the wrong version or the wrong thing. Okay, Rigidbody2d Cast. It returns an integer. We give it a direction. We give it an array that it will store the results of the cast in, and the distance to cast out. Returns a number of results placed in the results array. I think the array needs to be created. Results array will not be resized if it doesn't contain enough elements to report all the results, right? So we have no memory allocation for the array cast. We can store that. We can keep that array around of the right size or of enough of a size, and just like replace the results as needed every time we cast, right? So it's more efficient that way. So let's do that. First, I'll just make it in this function, and we can move that array out in the future. Array cast hit 2D array. We'll call it results. New array cast hit 2D. And we'll store like, I don't know, as many as 5. Probably only need 1 or 2 or 3, but there could be a lot of enemies. Maybe that should be bigger. Rigidbody2d Cast, and then we need the direction, which is direction, right? Because it doesn't need the start location, because it's casting itself, right? So it already knows its start location. It just needs the direction, the results, and the distance. So results and dash distance. And all right. That is a number, and if that number is greater than 0, okay. So we have these two cases. We hit some number of things in our array cast, or we hit nothing. Well, if we hit nothing, we know what to do, which is to do that. Just to we know we're good to teleport to that location. I already cleaned it up, dude. You don't need to. He's like trying to cover up his mess in the way that cats do. But if we did hit some things, we need to check that those things aren't walls. And I think we should do that. I think we should actually just do that with a contact filter, so that if I hit anything that is not a wall, it'll just ignore it. So let's do that. Let's make a serialized private float dash contact filter. That's not a float. That's a contact filter 2D. And we will just edit that in the inspector and pass it in to our array, right? It takes first direction, then. Yep. So now if we hit any things, we will know that the things that we hit are a wall. So we hit the wall. We'll let the filter figure out what is and isn't an enemy. I don't want to write that code. Unity can already do it. So let's take a look. Here is our contact filter. Does that screen magnifier break OBS? Should I just like zoom in? Okay, we're fine. Here's our contact filter. Our contact filter, much easier to edit in the inspector, and we're gonna use layers. So we'll use a layer mask, and we have a player layer, we have a player bullets layer. Let's make another layer for environment, I guess. And we'll say that the only thing that we should stop us when we dash is the environment. Cool. let's make sure the walls are in the environment layer. Change children so that the things that we actually collide with have the correct layer. That's important. Oh gosh. Oh, I'm sorry. I messed it all up. Come back to me. Okay. So if we hit a wall, if we have zero, more than zero, let's just for now assume that the first result is the one we want, because we probably only hit one. May not be a safe assumption, like in the corners or something, but we'll just say the first thing we hit should stop us. And I believe they're in order. And that would be results of index 0. Are they in order? Distracted by the cat. Well, let's just start with that, and we get weird behavior, we can figure it out. So we need to find the position to move ourselves to. Is that the centroid? It'll work for the circle. But if you have an odd shape, that's the collision point. Try the centroid. Because I don't want to go all the way to the collision point, because that's moving my center to that point. But I don't think that's going to necessarily match up to the rigid body's position. We'll have to explore that. For a circle, it'll be fine. But if we have an odd shape, I want to figure it out. Did I change my dash distance? Nice. So I can't go into the wall, but I can go up to, and it'll stop me. So that centroid still works because it is the center of the centroid of a circle is the center of the circle. But if we have another shape, that centroid is like, gosh, it's not like it's like the position the rigid body would rotate around. But that may not necessarily be the position that we want. Let's explore. Collider, distance from the ray to the impact point. Fraction, we could use fraction. We could just change our position a certain percentage, probably. Yeah, there's probably a way to figure it out. If we do distance from origin to impact point, we can just move that distance amount. I bet that'll work. Let's try that. We just move that distance amount. Let's see if that still works for a circle, then I bet it. Got to cast our vector 2 to a vector 3. Again, that movement's just my computer being weird. Oh, I keep forgetting to. Let's go. Let's leave it like that for a while. Let's I'm gonna write the other version and comment it out. Transform dot position equals results 0. Just have it there in the back. Great. Well, that is our dash mechanic. I don't like the right mouse button. We're just gonna make a dash button. So if we go to our project settings, input manager, let's get rid of jump, and let's call it dash. There you go. and dash will be the space bar. I think that's, I want to kind of separate it from. I gotta make this change outside of the dash distance 3. All right. So we have some bugs to work out next. The trail renderer probably needs some kind of reset. And we probably need to replace the dash instant teleportation with some kind of animation particle system, right? We can leave something behind that like fades out, and we can find the location we're heading to and fade that in. Maybe play an animation with an animator or an animation system. Maybe just use particles. For either of those solutions, what we would need is events hooked into our dash start, dash location, dash, and a dash info event that gets broadcasted when you dash. That particle effects and the sound things can listen to that event and they can play accordingly. All of that is a task for a later date. It's creating that feedback system, which is we're going to be creating, and will be a whole its own video here before an assignment where we use the feedback system to add juice to the game, and that will be one of the assignments that we'll be using in this project. So making the non-juicy simple version is fine with me for now. So let's do the cooldown. We got 20 minutes on the clock. Cooldown. We can do cooldown in 10 minutes. Let's add another float for let's call it dash timer, and then a private float that we don't see in the inspector. Time since last dash. And we might need to be getting that for the UI, so we can like charge up a little meter bar or something like that. But for now it'll be private. And we'll use the little underscore for private variables. In update, we'll take time since last dash, and we will increase it by delta time, the amount of time that has passed since the previous frame. Every frame. So this will go up 1 unit per second. It's a clock. When we dash, when we successfully dash, we will times dash equals 0. We'll reset it. Then timer isn't a good word. Dash cool down time. Dash cool down time. If dash cooldown time is larger than that's the opposite. If the amount of time since the last I have dashed is less than my cooldown time, don't dash. Else dash. I don't really want to bother wrapping all of this and moving that inside of this else statement because that's annoying. So instead, I'm just going to return. And when you return a function, usually that's when we have a return type and it gives us a value back as we use this keyword return and with the value after it. But for void, we don't have anything we give back, so we can have that be empty. But the statement still does another thing. And the other thing it does is it ends the function from executing. So when I type return, we won't keep running these other lines of code. It'll just stop. It'll just return. So don't dash, we will return. And that's it. So when we do dash, we will say time since last dash equals 0. I should check if our distant dash, if our results 0.distance is less than some small threshold. We just butt up against the wall and we can't spam it to be a timer, right? Does that make sense? Like if we dash into a wall, it shouldn't count as a dash. It shouldn't play a sound effect and play the music and do the thing, but you don't actually move. Maybe I'll comment this out for now. So dash distance 3, let's say 0. Third of a second. I can't spam it. Great. And then let's add another Boolean. Let's add another private float can dash, and we'll serialize it. Can dash. Should we serialize it? No, we'll leave it private. Can dash. And it should be true by no, can dash. And if we cannot dash, or if we cannot dash, float. If we cannot dash, so that's not can dash, or under the timer, then we don't dash. Okay. And now we probably can't dash. It's probably false by default. So we'll just set it to true. And then let's make a public void set can dash. Can dash. So now we could maybe turn this on and off by picking up an item or having an item. We could change this Boolean to be representative of our item held status. We could maybe disable the dash every time you use it. You need to reactivate it when you you dash and then you pick up like a Celeste. If you played Celeste, you have that extra jump and you can go into these crystals that float in the air and get that jump back, and you kind of chain them together. I could see something like that being interesting for this game, where you have to you charge up a number of dashes and you use them. For now, we'll just have it a Boolean. For charging, we need to make that an integer, and it counts down. But and for the cooldown, that'll just be a spammer. Without a clear vision of what this mechanic could be, I'm going to leave it fairly loose right now. I like the idea of a little, either 3 dots hanging out next to me that like go away as I dash a certain number of times and they slowly recharge. I also like the idea of a little ring visible around the player that that like recharges as we dash. Sorry, it's my space mouse, my 3D mouse sometimes acts as a joystick, which it shouldn't. Well, it should, but I don't want it to. I like this ability to dash past the mouse as a way to like quickly like get behind an enemy. Maybe enemies can turn slowly and we can use that to like give them the what's what. Give them the eyes. Anyway, there is our dash mechanic. Lots of playtesting to figure out if it's any fun in the game. Since we don't have such a strong vision, which is like a big mistake in game design. But we're learning the code parts of things right now. So I'm leaving it up. I'm leaving this project as a sample project. Students will take it in their own directions. Okay. As will I eventually. So anyway, 30 minutes on the clock. We did it, even with some cat distractions. We got the dash mechanic in. Excellent. Bye.